This lesson discusses the intervals or classes in histograms and their width or number. The disadvantages of the standard Excel settings are briefly explained using an example. Then, two charts are created and the interval width and the number of intervals are adjusted and compared. The Excel function frequency is also explained. With this knowledge, you should have a reasonable basis for visually presenting large amounts of data by condensing the data down to the essentials. The challenge is to keep as much information as necessary. Before we create a chart in Excel and make the necessary adjustments, here is an example showing the disadvantages of Excel's default setting. In the above example, the intervals were set automatically by Excel. In the image below, the intervals have been chosen and adjusted sensibly. It can be seen that the visual distribution of the values in the upper representation is not representative of the data set. Just as little is an accumulation of values or an average value recognizable. But why is that? Excel always assumes that the values correspond to a normal distribution when calculating the intervals. In the case of values that are not normally distributed, this leads to a non-representative representation. The problem with this is that you can't see how the data is distributed in advance, and you don't notice this error. Another disadvantage is that if data is compressed too much information is lost. In addition to the distribution, the exact position of the mean value or extreme values can no longer be recognized. This justifies the need to manually adjust the x-axis of the histograms in a meaningful way. An empty table has already been prepared for the creation of the histograms. Only the diameter measurements from the example have been entered in the first column. Let's start with the creation of the histograms and the adjustment of the intervals and compare them. Here you can see that the selection of the interval option has an impact on the display of the diagram. Despite the same number of intervals, the representations are different. If you specify the number of intervals, the interval width is calculated based on this number and the range of the data. With 15 intervals, the interval width in this example is 0.00933 mm. This may then deviate from a self-selected interval width despite the same number of intervals. After knowing the actual distribution in detail, the data can be further condensed with a known and acceptable level of information loss.